Just like in other problems we've done like this, we start by saying, well, if this is going to have a square root that is nicer than 8 plus the square root of 8 plus, a nested radical, then it's going to be in this form. So we go about squaring both sides to get rid of this radical so we can try to solve this. So when you square a radical, you just get what's inside it. So 8 plus 4 root 3. This, when I multiply it out, gives me 8 squared plus 2ab root 3 plus 3b squared. So that gives me a squared plus 3b squared equals 8. And ab equals 2. Because 2ab has to equal the 4 part, and the way that we're going to get the 8 part is by adding these two together, because neither one of these, assuming that a is not a binomial radical, is going to be give you a radical 3. So the 2ab root 3 is the only place you can get the radical 3 from. Well, when you start trying things, you realize that there's only 1, 2, and 2, 1. And if you plug these in over here, none of them work. If you do 1, 2, you get 13 instead of 8. If you do 2, 1, you get 7 instead of 8. So there is not a nice solution to this one. Thus, we've got to try some other algebra. And to do that, we can say that a equals b over 2. And if a equals b over 2, then that means we'd have b over 2 squared plus 3b squared equals 8. And so that gives me b squared over, oh, my bad, this should be 2 over b. And so that's going to give us 4 over b squared plus 3b squared equals 8. Clear the denominator out, so multiply through by b squared. That's going to give me 4 plus 3b to the 4th equals 8b squared, which is the same as 3b to the 4th minus 8b squared plus 4 equals 0. Well, that's a quartic, and there's not easy ways to solve quartics unless it factors nicely. When you consider this one, it does factor nicely. It factors nicely because 3b squared, b squared, and then minus 2 gives you what you need. And that equals 0, which means we can now solve these two quadratics because one of those two has to equal 0. That's the theory of factoring to solve a quadratic. And so you got 3b squared minus 2 has to equal 0. So b squared would equal 2/3, which means b would equal the square root of 2/3. Well, the square root of 2/3 just turns out to be the square root of 6 over 3. It would be plus or minus, but we can we know that we've got to have positives up here, and so it's going to be a positive value for our b. The negative value is not going to work. For this one, we get a nicer answer. B squared equals 2, so b equals square root of 2. So plus or minus square root of 2 plus or minus square root of 6. And the reason for that is if one of these two are negative, when we go find the a values for those, they would also have to be negative because a times b has to equal 2. So if we do this one first, you get a times the square root of 2 equals 2. So a equals 2 over the square root of 2, which just turns out to equal the square root of 2 when you simplify the radical. So in this problem, if a equals square root of 2, then b has to equal square root of 2. And so just to get us an initial answer, that means that you get square root of 2, because a square root of 2, plus square root of 2 times square root of 3, which gives you square root of 2 plus square root of 6. We'll come back to that in a second, but that is going to be a solution for us. The second possibility is this one. And so remember, if b is that, we'd have a times square root of 6 over 3 equals 2. So that gives us a equals 2. We multiply by the reciprocal of that. So 2 over 1 times 3 over root 6, which gives me 6 over root 6, which just turns out to equal root 6. So if b equals root 6 over 3, a equals root 6. And so if I come back up here and plug it into the a plus b, I get root 6 plus, that's the a, b, which was this, root 6 over 3 times root 3. Well, that gives me root 6 plus root 18 over 3. Well, root 18 is just the same as 3 root 2. And so I get root 6 plus 3 root 2 over 3. The root 3's cancel. So you get root 6 plus root 2, which is the exact same thing we got when b was root 2. So it turned out we didn't need to go through that because we just ended up with the same possibility as before. We can verify this is correct. If we square root 2 plus root 6, it better give us that 8 plus 4 root 3, the beginning part of the problem. And so when we square this, we get 2 plus 2 times, well, root 2 times root 12. 6 is root 12. Root 6 squared is 6, and so that gets us 8 plus 2 root 12, but root 12 is just 2 root 3, so that verifies that the square root of 8 plus 4 root 3 is root 2 plus root 6.